So you have the floor, Sarah.
Great, thanks very much. So great opportunity here to make this presentation. I was actually supposed to be making this presentation at the IADC HSE conference, the Asia one, back in February, but it was cancelled, and the rescheduled date also cancelled, so it won't happen again until next year. So we decided this was a good opportunity to use the presentation as it's on dropped objects. So today I'm going to talk about what we've been doing to reduce our high potential dropped objects in shell wells activities. So if you go to the next slide.
Yeah.
Okay, disclaimer, it's a very quick read. So what am I going to talk about? Yeah, I'm going to talk a little bit about the background, why it's so important for Shell, and then I'll talk about how we've been applying the hierarchy of controls to specifically around dynamic dropped objects. And I'm going to cover a few different areas: elimination on Let's Live Less, what we've been trying to do to substitute using innovative ideas, and then lastly on engineering and administration controls and focusing on failing safely, and then give a bit of a summary of how we did. So we go to the next slide. So I think here we're going to ask a question. Is that right, Joachim? Are you going to put the questions up? So I was going to start by asking, dropped objects is a key focus area for Shell, because we see a lot of high potential dropped objects when it comes to personal safety. But what I'm interested in your own companies is what percentage of here we go, there we go. What percentage of your high potential incidents that you have in your wells activities are related to dropped objects? So just interested to hear how big an issue it is for you. And did we get to see those results? Interesting. So a few people not sure, or they don't know, and then, like you say, pretty even split there between the percentages. So yeah, what we see in Shell wells activities is actually 2/3 or 66%. So I guess we would be in the 61 to 80% bracket there of our high potential incidents involve a dropped object. And that's why it's been such a focus for Shell over the years, and it still continues to be a focus. So if you go to the next slide.
Yeah. All right.
Okay, so this gives a little bit of an overview. So in the pie chart on the right, so I've got the 2017 data there. So you can see about 2/3 of all the wells high potential incidents associated with a dropped object in Shell operated activities. It was a little bit less last year, but still the majority coming from dropped objects. And then obviously dropped objects is something we've been working on a long time, not just in Shell, but we're in the Drops Asia webinar today, and the Drops Online group that we represent obviously started working on dropped object prevention a long time ago, and before Shell ever did. Actually, in Shell wells, we had the first drops manual back in 2009, so over 10 years ago, and we've been going through a process of having the manual out, doing online training. We had the drops campaigns that many of you may have seen, which were animations with good and bad when it came to different drop scenarios. We revised the manual. It gave a big focus on the contract ownership, and we've revised the manual once again to try and simplify as much as we could, and that has over time driven the frequency of the dropped objects we've seen has gone down and down, but we're certainly still experience quite a number. So we're always looking to see what we can do next. So I think we've got another question. Yeah.
All right, coming up.
Okay, so here what we're asking is, we're interested in, what areas do you see most of your dropped objects occurring? So I've put a few different areas where we see dropped objects occurring. So have a vote and see. Tell me where you have the most issues. So I'm interested in your your companies and where you see the key issues. So I think we can go to the next slide, Joachim, if you can do that. Doesn't spoil anything.
1 second, I went too far. There we go. Yeah.
Okay, so here I am sharing some of the Shell statistics. So this comes from an internal review that we did. So people might be aware of the term static and dynamic. So you can see on the pie chart on the left, we get about 2/3 of dropped objects are a dynamic type. And about 1/3 static, and then in those you can see I've put a bit of a range of where we have our issues, and you can see that lifting and hoisting and transporting objects is actually the area where we see the biggest issue, and actually that's one of the issues where we see the most of the high potential incidents. So when we say high potential, we basically mean it was an incident that occurred. Basically, we dropped something, it was heavy enough and dropped from a big enough height that could have killed someone if it had landed on somebody. Fortunately, very rarely do things land on people, and that's why we call it a high potential, but it didn't actually reach its potential. So we got the answers to share to see what other companies see.
Yeah, they're on the screen. Should be. Are they not?
No.
Well, I can share that.
Maybe you can just give us a.
I'll do it again, but similar
Oh,
to
there we
what
go.
you. Yeah, is there?
Yeah,
okay, great. Yeah, so similar to what you said, lifting and transportation.
So yeah, lifting and transportation of objects. So it's not just in Shell. It's good to see that actually is a theme across the industry, which doesn't surprise me. So if we go to the next slide, skip on again. So then we want to look at
yeah.
Okay, and get rid of the poll results, I guess.
Yeah. There we go.
Okay, so we really wanted to look at, to improve the frequency of dropped objects we were having. We wanted to look at what controls we were putting in place to reduce those dropped objects. So on the left is a little schematic that comes out of the Drops Online Reliable Securing book, and I'm sure a lot of people are very aware of this circle. And if we think about it related to static dropped objects, this is a process that we've been going through for a long time when it comes to, for example, the derrick. So we typically get an inspection company out, and they go up the derrick to see what's up there. They identify the items that could become dropped objects, and they look at them and they look and see if they can eliminate it. Does it even need to be up there? Can they substitute it with something else? If it really has to be up there, then they look at how they can control it. So they look for putting secondary retention on it, as well as the primary fixing mechanism. And then once we've decided it's up there, it's got primary and secondary retention, we go through a monitoring program, which is typically the weekly derrick inspections, and to ensure it stays in place. And then we start all again, maybe in 2 years' time when we get an inspection company out again. So I think for static dropped objects, that process is very well articulated, and obviously involves a hierarchy of controls in there. So on the right, this is the typical hierarchy of controls from eliminate, substitute, engineering controls, admin, and PPE. And we really wanted to look and see how we could apply that hierarchy of controls, not just to static dropped objects, but also to dynamic dropped objects. So I think we've got another slide now. Another question, yeah.
Yeah.
So which one of the hierarchy of controls do you think is most important when it comes to dropped objects prevention? So which one in your company are you spending maybe the most time on, or the most effort in to actually help you reduce the number of dropped objects that you see? How's that looking?
Yeah, so it's interesting. I maybe ask you maybe to elaborate what we mean by substitute.
I will show some examples. So where do people put the most, what do they think is most important? And I assume if you think it's most important, you put the most energy into it.
Are the results on the screen now?
Yeah, and now I can see them. Okay. So quite a lot of engineering controls. So 52% engineering controls, 44% eliminate. Okay, great. A few admin controls. Okay, interesting. Interesting. Okay, so let me share the journey that we've been on. So let me start with the next slide. So if we talk about eliminate when it comes to dynamic dropped objects, this is the first program that I'm going to talk about, and this is around Let's Lifting Less. And this program was started by the Shell team in the UK operations. And it's not really a hard concept to understand, but basically, if you don't lift it in the first place, then you can't drop it. And that's what we mean by eliminating and let's lift less. Now, it sounds simple, but the team came up with six areas they wanted to concentrate on doing that, rather than someone just saying, "No, I'm not lifting that." Of course, we still need to be able to operate and drill our wells. So they came up with 6 areas. And it goes through the whole life cycle of planning your work and your design. And you could say that actually this is really just good planning and management. And it is, but it's putting that focus into actually the amount that we lift. And if we lift less, we reduce our exposure. So changing the philosophy. So that's embedded in that, and that you want to put as much energy as possible into minimizing the lift. So don't put all the energy at the coalface, but actually think about it holistically from the bigger picture and see what you can do, and the energy you put into eliminate will pay off further down. Deck management, obviously very important, having a deck plan, not playing deck chess, not moving things 5 times once it's on the rig. You know, put it on the rig and put it where it needs to be, and avoid moving it. But obviously, who do you need to do that? You know, who do you need to collaborate with to make that work? Well, obviously the crews, they know where things need to be and where things need to go. And they'll also be fully aware of things that you do that are crazy, that involve a lot of extra lifts. Early engagement, very important with all your suppliers. You know, we get equipment from, many different companies that are providing services on the rig. So we need to make sure that they're aware of what we're trying to do. And it could be reducing the lift count by putting things together, et cetera, et cetera. Design, okay, so upfront engineering. So in the UK, they were doing a lot of abandonments, and actually they ended up engineering some of the solutions in that some of the items were never removed from the well in the first place, so then they didn't need to be backloaded. So then you're not lifting them. Logistics is very important, and making sure we have a designated person looking at it. I think that's an important part of it. And contingency equipment, yeah. In wells, we like to have a backup for everything. That's always been, that's a very traditional approach. So rather than just having the comfort of it being there, obviously you've got to get it there. It involves lifting. So what can we actually live without on a risk-based approach? So all sounds very good. Let's lift less. So let me share an example from our team in Qatar. And I think this is the next question. So we've got a jackup working for us in Qatar at the moment. And in a month, how many crane lifts do you think we make on that jackup? So this is a question for people to see what they.
Is it coming up? Yeah.
Yeah. I've got it.
Right,
yeah.
Good.
So just interested to see how many lifts people think that we do. And I can honestly say we really counted every lift we do. So it's a really an accurate answer.
All right. Is there any prize if you get it right?
No.
No. Okay.
Okay, let's see what people think.
Yeah, we'll share the results. Okay.
Yeah, okay, 41% think we're doing more than 2,000 lifts a month, and that's right. We were doing just over 2,200 lifts a month on a jackup, so quite a lot. So if you want to go to the next slide. So it may seem quite crazy to count the amount of lifts we're doing, and trust me, it took some convincing to get the crane operator to count the lifts, because they don't really see what's in it for them. But what you're really trying to do is it's all about changing this philosophy. If you don't measure something in the first place, how do you know you're getting any better? If you don't measure it, how do you communicate what the size of the problem is? When you're sitting in the office writing a drilling program and picking equipment, do you think that this could involve 2,000 lifts and the exposure that gives to people? Yeah, not necessarily. So yeah, you can see we split it up into lifts to and from the vessel, but also internal lifts. Some of the other sites, they've split it up into deck lifts and lifts going to the rig floor, just to try and get that granularity to see what are the different lifting operations we're doing, and where potentially there's opportunities to minimise. So part of their change in philosophy was all about counting. It's not a numbers game, but it does in the end of the day it gives visibility, and also you can see the general trend. Obviously you're not doing the same operation every month, so it's not an absolute number, but the trend, you can see the improvements that you're making. And then when they looked at the 6 areas they wanted to look at, some of the things that have been doing, you know, we always do DWOPs for activities. Well, now when they're planning a well, they do a workshop. Specifically, part of the workshop is around lift minimisation opportunities in each of their campaigns. They've been working a lot on consolidating tools and loadouts from multiple service providers and multiple product lines from one service provider into the same basket. On the design side, they've been mixing the mud onshore and sending it out pre-mixed rather than sending out chemicals and extra lifts. Very much working on the backup tools and leaving stuff at the base if they can. It doesn't take that long to get to the rig, so really using a risk-based approach, and also having this accurate deck plan and a vessel deck plan as well has really helped them. So that's some of the practical things that they've been doing, and they've been doing it about 6 months, and on the last campaign they'd achieved a reduction of around 40% when it came to the number of lifts that they were having to do. So a good result. Okay, let's go to the next slide. So substitutes, yes. So what does that mean? So this is an example from Brunei. Okay, so this is working with one of our service providers. So this is working with Franks. Running completions with a lot of control lines. And on the left is typically what that would have looked like. So what we've got there, 5 different control lines to run the completion. That means we've got 5 sheaves hanging up there in the V-door, slung up. It also means to get those 5 lines next to the completion tubing, we need some people to manhandle it in and get it around the clamp. So we've got what, 4 people there around in the red zone at the rotary table. So instead of that, on the right, you can see what we call the sheaveless. So there's no sheaves in the derrick anymore. So we reduce them as a potential dropped object. We've got the sheaveless control line arm that helps install the control lines. And you can see it's, first of all, we've got rid of the sheaves, but also the way it works is it also requires less people to be at the rotary table to get the cables in the right place. Just by the way it manipulates the cables into the right place rather than coming from afar from the sheave. So a very nice engineering design. Obviously still need people because someone's got to put that clamp round. It's not that there's no people, but we've certainly reduced the risk. So it's also faster, which obviously everybody likes. So it's not just safer, it's faster as well. So a nice solution on the substitute. We're still doing the same activity, but we're doing it differently. If we go to the next slide. Then we start looking at engineering. So I picked some of the engineering solutions that we've got in our operations. So on the left is a couple of examples in Russia. We talk about keeping people out of the way and failing safely. So, you know, at the end of the day, we still drop things still go wrong, but how do we keep people out of the way? So forklifts, a lot of forklift operations in people's yards, obviously on the rig in the sack store. And we often say, oh, people need to keep out of the way. But there's always people working in the area. So I quite like the red beam that comes down from the forklift on the left, which really clearly shows you where the exclusion zone is. So it's very dynamic and keeps up with the operation. The middle one is a crane hook in a workshop again, and this one it has a spotlight that comes down, and again when the crane hook moves, the hazardous area, it's written in Russian there as well as English, also moves around, and it tells you how to keep out of the way. The guy in the blue coveralls is looking at it, keeping at the edge. Again, letting you know where the hazardous area is. And on the right, when we had the Deepwater Nautilus working for us, actually still working for us in Brunei, in their sack store, they have also have a warning system set up where basically anyone working in the area has a monitor, and the forklift will automatically cut off if that person is in the area, if it gets into the red zone. And that is again, that's a commercially available piece of equipment that you can easily buy off the shelf. Go to the next slide.
Yeah. So just as a reminder from the earlier points, if you're providing solutions like this and you know or something new, love to hear from you.
And then at the very, well, not right at the very bottom, because obviously at the bottom of the hierarchy of controls is PPE, but just above that there is administration. And we spend a lot of time in our industry working on administration controls, if we think about all the procedures and stuff we have. But here I've got a couple of examples of how we are trying to make those administration controls more robust. So first one I'm going to talk about is called Own the Zone. So zone management, when it comes to dropped objects, has been around for a long time. It doesn't stop anything from dropping, but hopefully it keeps people out of the way should something drop. And I think we're all pretty used to the rig floor being the red zone or the restricted access zone. You know, you can't just walk up there when you want to. It's all about, you know, minimizing the number of people there and eliminate it and reducing the amount of time they actually spend in the red zone. All Own the Zone does is really, it takes it to the next level. It's not just for dropped objects, or it's not just for dropped objects on the rig floor. It goes to the whole rig site, and it covers more than drops. It can include any hazardous situation. So it really makes sure that the hazardous areas are visually marked. You know, it can be done through a sketch, it can be done through the matting, it can be done through barriers, but making sure that people know where the hazardous area is. And then the next step, making sure that entry is controlled to that hazardous area. So the entry and exit points is a singular entry and exit point where possible, and making sure access is controlled in and out. And lastly, having a single point of accountability to make sure that it's maintained as a barrier. So really, you know, rather than people thinking, well, I've signed on the permit, so I know I can go in that area, even though I know it's got some hazards, it's changing people's mindset into thinking that, you know, it's a hazardous area for a reason. And being very specific about whether it's a restricted access, meaning you can go in there if you needed to do your work, a limited time and number of people, or whether it's a complete no-go, no entry zone where people shouldn't be entering at all. And the next one, which I think is the last one. This is something we've been working, Transocean introduced a shell in the Gulf of Mexico, and the shell have then introduced it to some of our other contractors as well. And it's really goes the next step on the zone management, and it's about how we control and how work gets done inside a hazardous zone. We all know we have to work in hazardous areas for dropped objects, the rig floor obviously being the one that comes to mind the easiest. And this admin control is called a job by design, is the sort of overarching name for it. And what's key about it? Well, it realizes that, you know, people do have to actually go into the hazardous zone. So it says who needs to be there. So you can see it in the middle sort of area. It's got the actual people involved in the task. So they're the only people who should be there. It's got the key job steps on the left. So realizing that all operations we do are dynamic. People don't just stand in the same place all the time. They do move around. Making sure that people know what they're going to do. So under each people, it says what they're going to do. And then on the schematic, it actually says, you know, how they are going to move into the area in and out. Where's their safe step back area, and how do they interface with the machinery, and how the things that do move potentially in that environment. So being very specific around how people or which people and how they move inside that hazardous area. So going to the next level of detail, I would say. So that was another concept to introduce. So we go to the next slide. So that was a very quick journey through our hierarchy of controls for dynamic dropped objects: eliminate, substitute, engineering things out, and then the last one, trying to improve our administration controls. Now if we go to the next slide. So how did we do last year when we've been implementing these? I think some of the real highlights is that we started involving the full supply chain, which hopefully you can see through the Let's Lift Less a lot. A lot of front-end engineering involvement to deliver Goal Zero. So, for example, the sheathless control line arm, you can't get a piece of equipment like that from a service provider. Just like that, it takes a lot of energy from the front-end team to think about how they're planning the work. It's a real integrated approach to Goal Zero. And in the end, last year globally in shell wells, we saw quite a significant reduction in the frequency of high potential dropped objects last year. So we felt that, by putting our energy into dynamic drops, really thinking through the hierarchy of controls, that we've really made quite an improvement. But what I will say is that the work's never done. It's always a risk, and it's something we've got to keep working on. So that's me finished.
All right, thank you very much, Sarah. So I'll hand over to Steve to coordinate the Q&A session for this presentation. We'll give it about 5 minutes or so, and then we'll start the next presentation. But if we don't answer all questions, you continue to put them in, and then we'll revert back to that towards the end of the webinar.
Okay, folks, we have one question so far. If you have a question to Sarah about this her presentation, if you could just waggle your mouse on the screen where you currently can see Joachim, and you'll see at the bottom of the screen there's a little button that says Q&A. If you click on that, a pop-up box will appear, and you can write your question in. Okay, and we'll have about 2 or 3 minutes just for people to think if they've got a question, and pop the question up. In the meantime, there was a question from Dave, which was, does Drops have a website location where all of these great ideas that some of the ideas that Sarah was showing are listed?
Yeah, there is. It's called dropsonline.org, and I'm putting it in the chat box right now. So a lot of documents in there. Keep in mind, everything is free from copyright. You're allowed to use the content as you wish, and then yeah. So just give credit to Drops if you use it. But anyway, free to use it.
Okay. Any other questions? Or just 1 more minute. If anybody's got any other questions, just to stick on the list. We've got two or three questions so far, and then we'll go through them. Okay, there are 3 questions. The first question is from Sonny. Is there a list of common root causes that can be shared, specifically related to dropped objects, lifting and transporting objects?
Yeah, good question. So I think a good place to go to for that is if you go to the Drops Online website and you go to the recommended practice for what you should have in a Drops prevention plan. There is a section on lifting and hoisting and transportation, and it talks about some of the key controls that you should have in place. If I think about Shell, on lifting and hoisting, a lot of issues around the lift categorization in the first place. Was it a routine lift or a non-routine lift? Have we got the right controls in place if it's a non-routine lift? What's a non-routine lift? Is it a blind lift? Is it a heavy lift? Are you using more than one lifting device? And what you often find is that, people call it a routine lift because it's something they lift quite frequently, but that doesn't mean to say it can be routine. So, I would say, in my experience on lifting and hoisting, that the lift classification and making sure we have the right controls in place is a real common issue. Yeah, obviously competency training, make the person making sure that they're doing the lift plan, having a lift plan, a specific lift plan if it's a non-routine lift, very important. Yeah, many things. Transporting, get a lot of information out there around transporting and how you should correctly secure equipment when it's been transported, whether that's on a land operation or for offshore. So I think you'll find some good stuff on the Drops Online website.
Okay, second question is, does Shell crew have a routine for periodic drops inspections around the rig, or are they done by third parties?
Obviously Shell's contracting a lot of companies. So you know, we'd write in our contracts the requirement for the drilling contractor to ensure that there is a third party inspection. Our manual lines up with drops online at the moment, but that's every 3 years for a third party inspection. But obviously a weekly inspection of some type also to be performed. Doesn't mean to say that you have to do the whole rig every week. It can just be a section of the rig done on a rotating basis, but we do require some form of systematic drops inspection from our contractors.
Okay, thank you very much. I understand we want to carry on, so we have a few other questions, but what we'll do is we'll get those recorded and answered offline, or perhaps at the end if we have more time.
I'll start. So there were a few questions left after the webinar, and then Sarah had to leave early, but fortunately she agreed to jump on a call again to answer them. So we got 3 questions. The first question being, will the presentation material and write-up of the Q&A be sent out to attendees after the webinar?
So happily we can say yes, we're going to be able to share the video, so the recording of the webinar session, and obviously within that you get the slides come up and you get me narrating them. So that's how we're going to share the material. Obviously all the information on the VR training will be there too, as well as the answers to the questions.
Excellent, thanks. Okay, so dear Sarah, do you have statistics of static and dynamic drops incidents for Shell?
Okay, well, I get Joachim to bring up one of the slides we showed in the presentation here. So you can see on the pie chart on the left-hand side, it gives you an indication of the spread between static and dynamic drops. So this was 2018. You can see about 2/3 dynamic drops, and 2/3 dynamic is roughly what we've seen for the last few years, and that's why when we were looking at this, how we were going to improve our level of dropped objects to reduce them down, we knew we had to look at dynamic dropped objects, and that was an area that was kind of a little bit beyond the initial work that was done around static dropped objects and derrick inspections. So hopefully what I shared with you in the presentation, going through how we've used the hierarchy of controls to really focus in on the dynamic dropped objects, so it'll give you some inspiration how you can potentially tackle that issue in your own organization.
Excellent, excellent, thanks. All right, third question, are Shell doing drop survey on conventional offshore production and process platform without necessarily a derrick on it?
Yeah, again, a very good question. And, you know, something that's been around for quite a few years has always been a struggle. Often we'd have wells staff working on a production platform, whether it would be in this area with a tender assist rig going on a platform, and we'd often get many questions from the rig crew why Shell were making them as a drilling contractor work to one standard, and then they were on a platform, and could see that maybe the Shell asset itself was maybe not up to the standard that they were having to implement themselves. But a lot of work's been done on this over the last few years within Shell as a global company. It's been identified that drops is not just a problem for the wells staff and wells operations in Shell. Actually, it's a problem for all of our operations, and really pleased now that projects and the other groups within Shell, production being one of them, have seen that dropped objects is an issue, and I'll be honest, they're just starting their journey, and they're really focusing on static dropped objects to start off with, which is good because it's a good place to start, and they're slowly building themselves up to the standard of where wells already are. So they're playing a bit of a catch-up game, but it's certainly something that is now maturing, and they're doing more and more work on. So hopefully I can say in not too distant future that any Shell platform you'll go on meets the same requirements as we'd insist on in Shell wells.
Excellent. I suppose that creates a few opportunities for some companies here. We'll be pleased to hear that. So thanks very much, Sarah. And then, yeah, we'll close it with this. Thank you.
Thank you. Great.